Hello, everyone, and thank you so much for joining us today, and welcome to the latest D-Zone webinar. My name is Jason Cockeram. I'm the community manager here at D-Zone, and we're glad you're here. We've got a really relevant and an exciting topic for you today, and so we're happy that you joined us. If you're new to D-Zone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of knowledge resources for developers and really anyone who's passionate or involved in software development. We've got all things like ref cards and trend reports and thousands of articles written and published by members of our community. All of this makes us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today, and you can find them all at dzone.com/events. We've got things like fireside chats, virtual roundtables, and you might even see us at an in-person event sometime in the near future. So be sure to check out dzone.com/events for all of that information. Today, well, always, D-Zone is all about community. So today, I want to encourage you to get involved in the conversation. On the right-hand side of your screen, there's a box where you can chat with other attendees, and you can even submit questions to our presenters about anything you hear. And they'll do their best to answer them towards the end. All right. Now, if you have not heard of this thing called generative AI, it's been making a bit of a splash lately, and it certainly makes a profound impact on everything that we do as developers. And there are quite a few benefits that it can offer. For developers, Google Cloud Platform's Vertex AI is one of the best options out there to help businesses leverage the power of generative AI to help solve problems. Optimizing these powerful benefits often hinges on effective monitoring and observability. So today, experts from DataDog and Google itself are going to walk us through building some of these powerful AI-powered chatbots using publicly available documentation and some monitoring best practices to help you get the most out of your AI applications. Joining me today, I have Jason Hand from DataDog and Cody Hill from Google Cloud. In his role at DataDog, Jason leverages his expertise in DevOps, SRE, and AI to empower developers to build scalable, reliable, and explainable systems. Cody helps infrastructure and software companies integrate with Google's Vertex generative AI platform, and he's got more than 20 years of experience operating production infrastructure on a global scale, developing a deep knowledge of cloud, OpenStack, Kubernetes, generative AI, and DevOps. So at this point, I'm going to stop talking, and I'm going to turn it over to Jason. Jason, take it away.
All right. Thank you so much, Jason. And thank you, everyone, for joining us today. Appreciate the intro. And thank you, D-Zone, for hosting this. Welcome. And, I guess be prepared. We've got some really cool stuff and some really fun stuff to show off to you. I've got my good friend Cody Hill here from Google, who's going to be showing off some really awesome work that he's done here recently. And but I guess let's quit beating around the bush and just get right to it. My name is Jason Hand, and as introduced, I'm from DataDog, primarily focusing on SRE and DevOps, but also loving all this talk around generative AI and large language models and how we should be monitoring all that. So really excited to be here with you today and show you what we've learned and what we can help you understand and implement moving forward as well. And with that, I'm going to let Cody take it from here and introduce himself.
Yeah, thanks, Jason. Thanks for joining us today. Yeah, name's Cody Hill. I'm a solutions consultant at Google Cloud, mainly focusing on generative AI capabilities and working with partners such as DataDog to adopt our technologies and build really cool things. So glad to be here.
Yeah, thank you, Cody. Really excited to work with you. We've got some awesome stuff, like I said, lined up for today. We got about 45 minutes or so of content that we want to work through with you. Here's a real high level of what we're going to be talking about. Cody, like I said, he's got some really cool code that he's put together using GCP and a bunch of cloud functions and stuff that he's going to go into more in depth just around building this generative AI chatbot. Then we're going to spend some time talking about how to monitor and analyze and what are the different things that we have available to us through DataDog and what's important to look at when it comes to building these types of applications. And then we'll save a little bit of room at the end for questions. But I will say that if you've got questions, feel free to drop those into the chat. We've got some moderators who are watching that and can pass that along to us. But if you'd like to save questions to the end, that's just fine too. So with that, Cody, let's explain a little bit about what we're doing today. I know people already are aware we're doing a generative AI chatbot, but I think one of the pieces of this puzzle that is important to explain early on is what we decided to do is build a chatbot that actually leverages the DataDog documentation that's available out on the web as its knowledge base. So we should be able to have this Q&A with a bot to understand exactly what's going on in the DataDog docs. So you want to explain a little bit about that? I've got the diagram here of what we'll go into deeper detail about this, but maybe you can kind of explain what's going on before we kick things off.
Yeah, for sure. So what we're doing today is called Retrieval Augmented Generation, or RAG. So essentially, we're going to be fetching some information from a knowledge base. In this case, it's the documentation from the GitHub repo that DataDog has. It's all open source and public. And then we're going to be asking questions about that. But in order to do that, the first thing we have to do is we need to embed all of those documents. So we'll be talking about what embedding is in the future or during this talk. And then we need to store them somewhere so that we can retrieve them. And so we're going to do this live, right? So that's always exciting. And so this does take a little bit of time to run. So we're going to do something a little unorthodox and kind of start with me sharing my screen and kind of kicking off this initial deal. And then we're going to jump back in and start explaining kind of what's going on. And then we're going to do a demo of showing off the code, showing off how the application works. And we should be finishing this up with asking questions to the chatbot.
Excellent. Well, I'm going to let you take control of the screen here so we can take a look at what you're kicking things off.
Beautiful. Yep. So let's go ahead and do that here. So what I'm going to do is first thing I'm going to do is connect to the database. We're using the AlloyDB database. And I want to make sure that, there's nothing up my sleeve, right? So I'm going to drop the database. The database name is called PG Vector, and the database is dropped. We'll go ahead and do that again. We get an error, it does not exist. So we're starting out fresh. We have no database. So if my ingestion doesn't work, then we're not going to have a demo. It's like living on the edge there. So that's great. So we just dropped the database. Now I'm going to actually hit a Google Cloud function. And the only variables that I'm passing in is the bucket name and the name of the bucket. So DDDocs, it's the DataDog documentation. And we'll be using that to ingest, right? So I'm going to go ahead and kick that off. This is going to take a few minutes. So while this thing runs, we can get back to the slides and kind of walk you through what's going on there.
Yeah, and I just want to sort of jump in here, Cody, and point out that the reason why we're sort of jumping right into the demo here is because some of these cloud functions, some of the different things that are going to be running, we'll be able to see that in pretty good detail once we switch over and take a look at some of the dashboards. So just to keep everybody in line here, why we're doing things in a certain order is we want to be able to show you some stuff. And so you can see how this is all working in real time, live and cloud functions. So just a little bit of pre-context there.
Yeah, that's great. So if you want to throw those slides back up there, Jason, we can kind of march through them.
There we go. All right, so we just kicked things off, and let's take it from there.
Yeah, so today we're going to be talking about building that generative AI chatbot. But in order to do that, next slide, we'll need to kind of explain, what it is we're doing here, right? So everyone's been talking about large language models for about a year now. So I'm assuming everybody here is an expert, right? But if you're not, the key takeaway is that these models are trained on very large data sets. Next slide. And with that, these large data sets essentially have made these models build these emergent capabilities. And they're things that the models weren't necessarily trained to do. For example, they can do reasoning and logic, and they understand the human language, which makes them much easier to interact with, right? All you need is English. So Google's been doing this for quite some time. We pioneered this technology back in 2017 when we came out with the transformer architecture. So all of you nerds like me may have read the paper that attention is all you need. And that's essentially when we launched these transformer models. Google's been very active in the space ever since. We built BERT in 2018. Our latest large language model is BARD that you all can go play with and kick the tires. And we've really been active in this space. just want to hammer that home that we're pioneers here. So this is our family of models, right? So we have our Palm 2 is our flagship model. And then we have our Cody model, right? Not, I hope I inspired that name, but it's for code generation. And then we have the Imagen model that will actually produce images from natural language as well as edit images using natural language. All of these models feed into our 3 series of or categories of products. Up at the top, we have Bard and MakerSuite, which are really hobbyist tools and things for consumers and developers to consume. And then in the middle is our enterprise productivity suite, right? So this is where you can use these models to help you at the workspace, either in generate emails or book things on a calendar, or generate slides and things like that. And then really what we're focusing on today is going to be the AI experience with AI builder experience with Vertex AI. Okay, so this is where you as a developer can actually take these tools, build an enterprise application with our models. And just a little note on, you're going to see some names of models and like, what does that mean, right? So we name all of our models based on first the function they perform, right, or what they're used with. So it's either code generation or text or an embedding model or an image model. And then it has an animal name, and that animal represents size and speed, right? So a gecko is really fast, so it's a small model, has much fewer parameters. But it runs faster, right? So it's a fast but small model. And then bison's a fairly large size animal. It's not super fast, but it's fast enough. And otter's somewhere in between. And we also have our unicorn model that's wicked fast and extremely large, right? So it's a unicorn. So that's out there as well. And then we have a revision number, right? So we're 001, 002, so on and so forth. So if you've built an app on a specific model, you're not going to have to rebuild it and have your application break once we rev to a newer model there.
Yeah, and I also want to mention that when it comes to choosing these models, there may be some considerations when it comes to monitoring what exactly you want to monitor, what's important to you. Whether it's speed or the cost or the size of these types of things, they are going to play a role in the types of stuff that you're going to be paying attention to. So just something to keep in mind as we start to look at actual dashboards and the integration a little closer later, that there might be some slight variances in how we design those based on the choices you make with your models.
Yeah, that's a great point. Great point. Great. So what are text embeddings, right? So we need to get into this, kind of explain what embeddings are so that we can, because we're going to be using those to build our chatbot, right? So basically we're using a vector embedding, right? So a vector is a mathematical object that has both magnitude and direction. So think a graph, right? So if you have a graph, you have an XY axis. These embeddings that we're using actually have 768 axes. So you think about it like a ball with lines coming out of the center. And a vector embedding is a specific type of vector that's used to represent any kind of data, right? So numbers, text, images, video, anything that you can kind of see if it's similar, right? The next slide. Right, so this is the slide that Google likes us to use, but it's really talking about kind of how these embeddings work on that graph, right? So here we have 3 axes. We have movies, we have music, and we have actors. So if we were to say something like Chris Pratt, right? So and then you were to say maybe Guardians of the Galaxy. And then I can't remember one of the songs that's in that movie, but or those movies. But you would then have these all kind of they're all kind of similar, right? So that Chris Pratt is an actor inside of that movie, and there's a lot of music inside of that movie, and so they are kind of similar. And the analogy I really like to use to explain this, I think is far more simple. Is if you have some animals, right? So if I say dog, cat, and alligator, right? And then I throw another word out there like pet. Dog and cat are going to be much more semantically similar. It's going to be closer in that vector space to the word pet than alligator would be to the word pet, right? Unless this model was trained somewhere in Florida, where alligators may be pets. But that's basically how this works, right? So that's a very simple scenario, right? But in this case, we have 768 different vectors, and we're going to be measuring the distance between those to see how similar they are, which takes us to the next slide. Yeah, so vector similarity, right? So this is a pretty simple concept, right? It's you have all of these on that three-dimensional space, and then you're taking a line from one vector embedding to the other vector embedding and say, what's the distance between the two, right? That's how similar they are. So when you're doing vector searching, right, you're basically saying, I want the things with the lowest distance, and that would make it more similar. So, and kind of the way this works in the real world that I'm sure you've all seen, if you've ever used an online streaming service and they've recommended the next thing to watch, they're not doing that based off of the title only, or only based off of the actor name and looking that up in a database and see what actors match. They're actually taking all of those factors, the genre, the description of the movie, maybe the runtime of it, all of these things, and they're seeing how similar they are to other movies in that space that you may like. And so that's how they're doing this. They're doing a vector similarity search to provide that. Okay, next slide. All right, so you saw this slide earlier, but I'm really going to dive into this guy now. So this is the architecture for loading our documentation into our AlloyDB database so that we can start querying it and asking it questions. Okay, so top left, we just have a cloud storage bucket, has our DataDog documentation. And then we're going to hit the cloud function there that's going to download and push all of the documents from that cloud storage to PubSub. Okay, so we're gonna hit, you saw me do that. I did that REST API call where I pushed the bucket name, and we're going to go ahead and index those. Now, LangChain is going to be a big component of this. It makes life very easy. So LangChain is a library that allows you to chain together different functions for large language models, so language chains, right? So we're going to be using LangChain to do this. And so LangChain is actually going to read all of the documents, and then we're going to push each of those documents to PubSub one at a time so that we can kind of scale out. We can fan out our operations because believe it or not, DataDog has about 1,800 pieces of documentation. And if we were to have to do those serialized, it would take quite a bit of time to do that. So we can go ahead and utilize PubSub and trigger a cloud function based off of each document so that we can do the second step of this, which is to split those documents into chunks. So we're going to break them into smaller chunks. That chunk size is about 1,200 characters. And then we're going to store those. So we break them into chunks. We then push them to our embedding model, right? So up at the top right, we have our Gecko embedding model that's going to do that vector embedding that we talked about previously and give us back that numerical representation of that embedding. And then we're going to finally store that inside of AlloyDB. Now, LangChain does all of that for you. So we'll be diving into the code in just a minute. So next slide. Okay, so once this is done, we now have to start using the documentation in its new form inside of AlloyDB. And this is kind of the flow chart on how that's done, right? So you ask a question. That question is then sent to the embedding model as well to get a vector representation of the question you have. So then we can use that vector representation to query AlloyDB and say, hey, give me the most the closest distance to my question, right? So what content makes the most sense to answer this question? Okay. AlloyDB then sends back one or more pieces of documentation that will answer that question for you. And then LangChain will then take that, pass that to our text bison model, and along with the original question, and then text bison will give an informed answer with that, and we'll then pass that back to the user. So that's our application there. And then we're going to jump into a demo next, I think.
Yeah, I think it makes sense now to jump right in and show some of the code. You know, we don't have a ton of time to go through line by line with everything that you've got, Cody, but I think some of the highlights is going to really help people understand what you just showed off and what you described.
Yeah, so let's go ahead and do that. So let's, we have three functions here that we had talked about, right? So we have our push docs function. So let's go ahead and open that guy up. So this is the main cloud function here that we executed when we got started here. So the first few lines of code really aren't that important. We're just getting some variables and storing them from the environment, as well as that bucket that we posted. But we do have to do a couple things here. We need to set up the database that we're going to use, because remember I dropped it from the beginning. And we need to install pgvector into the Postgres database. So let's go ahead and look at those. So this is the code to do that. We're connecting to a database. We are seeing if the database exists or not. If it does not exist, we're going to simply create the database. Pretty straightforward. Once we have that, we're going to connect to that database, and then we're going to create the extension, if it's not already installed, called vector. So that's all there is to getting pgvector up and running. One thing to note that took a day out of my life that I'll never get back is that when you're doing both of these commands, you need to make sure, if you're doing this with Python and not from the Postgres command line, which you could totally do, is you need to make sure this connection auto commit is set to true, or else the database won't be created and the extension will not be created either. So little tech tip there. Once you have that, we need to download the documents. Nothing real special happening here. We're just connecting to GCS, downloading each of those documents locally so that we can load those documents, okay? So when we load those documents, this is where LangChain comes in. So we're setting up LangChain. We have debug mode and verbose mode so we can kind of see what's going on. We're giving it a directory path, and we're saying grab every MD file in this path, and I want you to do a text load on those. So load the text from every .md file that you find. And let's go ahead and return that list of documents that we have loaded here. Okay, so once we have that list of documents, we're then gonna push those documents over to PubSub. So pretty straightforward here. We have a topic that we're going to push these to, right? And we are going to basically, for every, sorry, I'm looking at the wrong thing, right? So for every document that we have inside of docs, we are going to do a dill dumps. Dill is, if you've ever used pickle before, dill is the new hotness. It works better than pickle. It allows you to take a Python object and put it into a format that you can transmit over a network or save to a file. So we're going to get that Python object, we're going to shove it into PubSub and rinse repeat. So every document will become a new message inside of PubSub. Okay. So with that there, let's go ahead and see if our, hey, status success. So that API call that we did earlier succeeded, right? So I'm going to flip over to this beautiful dashboard here. Let's set this to the past 15 minutes. Yeah, and let's kind of, maybe it's been a little longer than 15 minutes. We'll go to the past hour here. Okay, so let's look at this dashboard, because I think this is where it's super important to kind of see what DataDog can bring to the table here is we have all of these cloud functions that got executed. So I hit the, right when we jumped on this webinar, I hit the push docs endpoint, and then it did its thing, pushed everything into PubSub, and then the store doc, which we haven't looked at yet, went ahead and started storing those into our database, AlloyDB. So about almost 1,800 pieces of documentation. Now we have a 45% warning rate. And the reason for that is that we have only allowed about 20 cloud functions to run simultaneously, so that we're not to overload the quota that we have for the embedding endpoint. So these are basically saying, hey, like I can't run, I can only run 20 at a time. You want to run 1,800 of them, they have to back off, they have to wait, and the next one will take forward. So you have a ton of metrics there. You could see that the database CPU went up a little bit. Its available memory drops, we consumed some memory. File system kind of grew slightly, and then you can really see the transaction count of us shoving those into the database, right? So AlloyDB is being monitored here. You can see us downloading all of those documents from cloud storage. So that's being represented here. And then you can see the pub sub queue grow as we're shoving messages into the queue, and then the cloud functions are draining them out of the queue. So we have everything in a single pane of glass to view this. And then we have all of the predictions that we did, right? Getting all of those embeddings using that text gecko embedding model, and the latency of this. And if you notice, this latency is not measured in milliseconds, it's actually measured in microseconds. When I said the gecko embeddings was a fast model, it is, it's super fast.
Real quick, Cody, this is super cool stuff, but I wanted to point out to our audience, we did choose not to get too elaborate and go too crazy on this dashboard, but we could have added some stuff that really helps us understand what's going on more at the infrastructure level. Obviously, we're looking at ingress and different things with the databases. We're looking at some of the database memory allocation, things like that. But we could be looking at the actual, GPU or CPU, memory usage, that kind of thing, latency with the calls that we're making. So there's more stuff that we could be looking at that's really part of the Google Cloud Platform integration with DataDog, as well as what you're pulling up right now, which is the out-of-the-box Google Cloud Vertex AI dashboard, which you can see has so many good things right there ready for you to just replicate, duplicate into your own dashboard. So we're kind of, just paying attention to the time. We don't have a lot today, so we're showing you what we can, what's really important to the bot. But just know that there's all kinds of things that we could be really doing a deeper dive in to understand what's going on behind the scenes under the hood that's really running this bot, and also the functions that are pulling down things. If you didn't have them running in cloud functions, we could do all kinds of fun stuff. But for the sake of time, we kind of chose this route.
Yeah, it's a good point. So yeah, ton of stuff there. That Vertex integration that we showed off is brand new. We announced it at DataDog Dash last month. So super awesome integration that we have there. Great. So now I'm back into VS Code to kind of show off that second cloud function we talked about. So this is where we're receiving that code or that message, right? So before we did a dill dump to dump that object into an object that we can pass over the network. Now we're doing a dill load. So we're storing that into this doc here. Again, nothing interesting here, grabbing some environment variables. And then we're going to break this text into chunks. So this is where LangChain makes life super easy. We're going to break this text into chunks. We're saying, hey, I want to use the text splitter, the recursive character text splitter from LangChain. I want my chunk size to be, in this case, the environment variable set to about 12,000 characters. And I want to overlap each chunk by about 10%, so 1,200 characters. So if you have 3 chunks, the chunk in the middle is going to have 1,200 characters from the first and 1,200 characters from the last chunk. So pretty simple. We take that document, we shove it here, say, give me the text, and we return that text. It does all the heavy lifting for you. Then we need to save that document to the database, right? So we say, hey, we want to use the Vertex AI embeddings to create the embeddings out of those chunks. We want to connect to Postgres with all of our user password and so on and so forth. Then I want to use PG vector and say, I want to take PG vector from text. I want to store all of this inside of the database. So this is the text I want to store. This is what I want it to do. And then we have a collection name. This collection name allows us to separate different collections of embeddings so that we can know what the chatbot, what collection the chatbot should be asking questions on. So you might have a collection for your external knowledge base, a collection for your internal knowledge base, and maybe some other collections with other types of data that you have. You could store them all into AlloyDB and separate them by collection name. So that's it. That's all the code it takes to store everything inside of PG Vector, right? Pretty straightforward. I think we're talking about, about 20 some odd lines of code. Pretty cool. All right, so we're going to kind of do a big reveal here and jump over to asking a question. And because I don't have two monitors, I'm going to show you the questions we're going to ask. So we've got a couple questions here that we felt kind of show across the board from the documentation. If you have specific questions that you think would be interesting for the DataDog documentation, put those in the chat. Maybe we'll try them. All right, so the first one is, how do we configure monitoring for GKE Autopilot? So I'm going to go ahead and hit send here. And it's going to, this is where I get nervous because, hey, there we go. All right, so it's working. So we get the question is, how do we configure monitoring from GKE Autopilot? That's the question we asked in nice DataDog purple. And then we get Bits, the DataDog mascot, is going to answer our question. And here are the steps to configure monitoring for GKE Autopilot, right? So I used to be doing Kubernetes, so this is very interesting to me. And so it actually got this from the documentation. We have, it tells you, use this DataDog agent.yaml file. That agent.yaml file will look something like this. And then it, talks about how you can, create dashboards and visualize things and all of this. So very helpful question here. Let's go ahead and we'll skip one for time. And let's say, what's the retention policy for trace metrics? It's a very simple question. Should be a straightforward answer. So the retention policy for trace metrics, they're 15 days. So that's the default. That's good to know. I didn't have to, crawl through the documentation and try to find that. It was very easy. All trace metrics are stored for 15 days. Beautiful. How does DataDog secure my data? DataDog secures our data by doing all kinds of stuff. So traffic's always initiated by the DataDog agent, right? So it's never initiated coming backwards. Everything's SSL encrypted. All communications done through HTTPS, and we do not retain any passwords. So thanks, DataDog. So this is all just some questions that we can ask. And then we have a goofy question here, right? Let's figure out what the price of tea in China is, right? Oh no, what'd I do?
We tried to get fancy.
I closed VS Code. Command Q is very close to, yeah, that's, hey, at least you knew it was live, right?
That's okay. Yeah. Well, and we chose to ask this specific question because the point is, and maybe we'll get to show it here, is the way you've designed all this. First of all, it's pretty clear that it's not just pulling in a copy and paste or a scrape of what you find on the DataDog documentation website. It's clear that this is being built through the generative AI. And the question about the price of tea in China is really to show you the scope of the project, and that it really is only going to have answers that are relevant to the stuff that we asked it to pull down and create those PG vector embeddings and all that kind of stuff. So,
yep. So let's see if we could do that one more time without closing VS Code, because Command Tab is right next to Command Q. So don't do that in the middle of a presentation. So let's see if we can get this thing going. So what's the price of tea in China?
I think you might have included all of it. I think you copied.
Oh, I've included all kinds of stuff. Let me, well, it answered a lot of questions. Okay, so let me try that again. What's the price of tea in China? Look, it answered, I didn't know they would do that. It answered all the questions. But here we go. I'm sorry, the provided documentation does not contain the answer to your question. So yes, if you're building a chatbot to put on your public internet, on your website, people aren't going to be able to use that chatbot to ask all kinds of goofy questions and waste your resources. That's kind of the point here.
Yeah.
And we were going to quickly jump through the code to generate this web UI. And really, there's two functions that we care about. Okay, so the two functions we care about is so if we've posted a question, right, we're going to answer that question. We care about that. And then no matter what, we have to paint the user interface. The web UI that you see is being generated by Python and the Flask framework. So either we need to paint that web UI to say, hey, ask me a question, or here's your question and here is your answer. So let's quickly go to the answer question chunk of code here. It's pretty straightforward. We're authenticating to our AI platform. We are setting that we want to use Vertex AI for our embeddings. We're storing the question that came in. We're doing that same connection that you talked about, or that we showed earlier for PG Vector with that same collection. And we're creating that same exact object that we used before for PG Vector. So nothing new here. Now, what we are doing that's new is we're, instead of storing things in PG Vector, we're using it as a retriever. We're retrieving information. And we're saying we want to do a similarity score threshold. We want to return 2 documents if they meet the threshold. And we want to make sure that they're a 58% relevant. This number is backwards, in my opinion. The higher the number means the more accurate of a match. In my opinion, this should be distance based on the science, and the lower the number should be better. But that's how this works in LangChain, so just keep that in mind. We have a prompt template, right? So you do need to give those guardrails to your prompt. So what we have here is we have an instruction section. So you're a helpful, cheery technical assistant. Only use the following pieces of documentation to explain the steps in great detail, how to answer the question at the end. Do not use your own knowledge. It will try to use its own knowledge and make things up. It will try to hallucinate. If you tell it it's a technical assistant, it will be a technical assistant, whether it has the right information or not. So that's important. Only use the context provided. If you don't know the answer, just say that you don't know. Do not try to make up an answer. Okay, so that's important to kind of give, to ground the large language model. Those are the instructions that we're giving it. We're then passing it the documentation dynamically. We're passing it that question that we got, and then we are asking for an answer, right? So this is prompting the LLM that you need to complete this prompt by filling out what comes after the answer, okay? And so we're then just doing a string replacement for those variables. We have the context and the question. We're passing that those arguments for that new prompt that we have into this retrieval QA from chain type. We're using the Vertex AI large language model, right? LangChain can use a lot of different language models. We want to use Vertex AI, and we want to set the maximum output tokens to 2K, right? So we support up to 8K now, but 2K is fine for output. So a token is about 4 English characters, right? So the output of this should be able to be about 8,000 characters. So pretty large output like we saw previously. So we're using the retriever that we defined up here, the PG vector as a retriever. We're using the chain type of stuff. We're stuffing things into the prompt. That's what that means. And then we're going to use those arguments for that prompt. We're going to run our query and return the result of our query. Then all we're doing once we have the answer is coming up here and painting the web UI, right? So if you've ever done HTML editing before, we have some divs. Those divs are being defined and we're pasting in the question. We're converting them to Markdown, right? So they're nice and pretty. And then we're putting the answer in and then rendering that template and passing it back to what you see here. That is our live demo.
That's awesome. Cody, I appreciate you showing all that to us. And we kind of skipped over at the beginning of this where the demo that you just showed today is really just a kind of expansion on another demo that you gave at this most recent Dash. I don't know if you want to just talk about some of the differences there or what sort of inspired that initially.
Yeah, for sure. So at DataDog Dash, I thought it would be really awesome to be able to ask a question about a podcast. You ever listen to a podcast and you go, somebody said something about this topic. I don't remember the exact phrase. And I don't necessarily remember what podcast it was or how many minutes into that podcast. Do you ever have that problem?
Pretty often.
Yeah, I think everybody that listens to podcasts has. So I said, okay, it'd be really cool to use all of Google's latest LLM technology to solve that problem. And it makes for a great demo on stage at Dash. So we use the new speech to text Chirp API that Google came out with that's uses large language models in the background to enhance that transcription, right? So if you've ever seen speech to text before and somebody like me slurs their speech or speaks a little goofy or fast, and it puts really weird words inside of that transcript. Well, a large language model knows what you said before that, what you said after that, and can infer that those weird words don't belong there. These are probably more likely the words that you need. So it makes really great transcripts. So I downloaded all of the Google Cloud podcast, fed them into Chirp. I did the text embedding manually using my own Python code, and I didn't use LangChain, which took a lot of work. I then stored them into a database manually. I then had to build everything and do it all manually. It was probably 20 times to 40 times the amount of code to build that demo that is essentially what you see here with LangChain. Made it super easy to do. And so that's really why I wanted to revisit this, use the newer technology LangChain, and kind of use a slightly different use case of documentation rather than a podcast.
Yeah, and we appreciate it. I know folks at Dash really loved this demo, loved seeing how it all came together. Obviously, Google Vertex AI is really powerful. We're just showing off kind of, small area of it. In the amount of time that we have left, though, let's just talk a little bit more about some of the things we can do when it comes to monitoring and some of the stuff that we've talked about today. So Cody's already done a great job of showing off all kinds of code, but he also showed you some of the things within DataDog when it comes to our dashboards. If we've got time, maybe we could switch back and at the very end and just show like creating something from scratch and what it's like to, add a widget or something to our dashboard. But most of what you showed and what, we kind of want to share with everybody is that the integrations for Google Vertex AI is already there with a lot of great out of the box stuff that goes automatically into your dashboard, but you can create more when it comes to understanding what's going on inside Google platform, Google Cloud platform as well, just through their integration. And I've got a few links here. In fact, let me put those into chat just so I'm not sure if I can share links. I think I should be able to, but let's try it. If not, maybe our moderators can help us out here. There's 4 links there. I might have copied all of it a little bit weird, but the first one is going to go to Docs just to take you to our integrations. But this one here on our screen, if you were to use that QR code, this will take you to the actual integration for Google Vertex AI right within our documentation. So you can go and understand a lot more about what's going on there. And if you were to then kind of go exploring around a little bit more, the second link that I think I included there is going to take you to a blog post, which we've got. It's been out, I don't know, sometime in August or so, but does a really great job of taking you a little bit deeper into some of the things that are available within that integration with Google Cloud Vertex AI. So I encourage you to go check that out, give that a read. There you'll see a little bit more about what all the things and widgets you can find within our dashboard, how they work, what they're intended to tell you about, and that kind of stuff. And then this is the link I was mentioning before that takes you into the integration docs where you can understand how to configure it. There's really not much you need to do. Most of it's kind of set up for you. If you've got your Google Cloud Platform account already in there and configured, there's not much else you need to do. So with that, Cody, let's just take this last couple minutes here and kind of highlight some of the things that we went over. I know there was a lot that you shared in terms of what's going on when we're building this generative AI chatbot. There was the whole bit about large language models. Obviously, we're all very familiar with those. They've become, sort of front and center to a lot of what's going on in the tech world. We talked about Google Cloud's AI portfolio and all of the things that they've been doing for years now, really leading the movement when it comes to a lot of this stuff. So, it's not just with these large language models, but there's all kinds of really cool stuff that Google Cloud AI has their hands in. We talked about the text and the vector embeddings, which is kind of key to the demo that we showed off today. in terms of taking those tokens and that text and making sure it gets put into a vector database or some sort of embeddings platform where you can go and retrieve that information. It's kind of the new way of retrieving data when it comes to this type of stuff. And all of that was running in cloud functions, running on GCP. Previously, when we were testing this out, Cody was doing it all running locally. I guess the chatbot itself interface was run locally in this one, but that was just for the safety of the demo. We didn't really want to go too crazy.
Yeah, if I published that cloud function, I'm sure you folks would have a good time with it, and I wouldn't get through my demo, right? So the key takeaway there is we don't trust you. But so this entire thing was completely serverless, right? So there's no aspect of this infrastructure that you need to be, carrying and feeding for. You're not upgrading operating systems. You're not doing any of that. With that, we get all of the metrics from Google Cloud pushed to DataDog. So you get all the visibility that you need, and none of the heavy lifting of managing that infrastructure. So I think it's a pretty great deal there.
Yeah, exactly. And I think I did copy and paste those links in wrong. So let me get those for you here in just a second too. But some of the things that I kind of mentioned that will just, as far as takeaways, we've got great integration with Google Vertex AI out of the box. It's ready to go. Very little configuration you need to do. It's got some really great dashboards and some really great documentation as well. Cody did have a few different links here that I wanted to share with you. That you can go learn more about Google Vertex AI as well as see some of the samples that they've made available to us, which are really cool. So go check those out. They'll be available. I know the slides and the recording and everything, we'll be able to get that to you afterwards. So, and then these are the links that I had pasted into chat a little bit earlier. Yes, Cody just popped to the actual correct links into chat for us. So thanks, Cody. And you can also use the QR code there. But basically, these are the main three things that I was trying to share with you previously. And with that, I know there was a couple of questions that came up. We don't have a ton of time, but let me get to just the first one from Chris. He wanted to know, how does the QA, how does the bot tell the model of incorrect output? Is the model retrained, taking that into account?
So in this demo, we do not have that set up, but Google has released the human reinforcement feedback to actually tune the model further. So if you've seen, thumbs up and thumbs down on our Bard consumer product, same type of thing. You can give it a thumbs up, thumbs down, give it some notes, and that will go into making that model better and better. I didn't implement that inside of this use case, but it is something that you can totally do.
Okay, great. And also the question came up, well, first of all, will these slides and is this project available? Is the code available? We will make the slides available to you. I think D-Zone's going to reach out to you and provide pretty much all of the resources that we've shared today. And I will say, in terms of the code, Cody, you can jump in here, but this is not code for reasons that we can't just put out on the internet for everybody to copy. However, it is available through this video, and if you want to reach out to us directly, we can probably hook you up with what you need to get you pointed in the right direction.
I'm not a real developer. I just play one on webinars. And so the code that I write is not up to Google's standards. And so publishing those on the internet is a no-no for me. So, but I could share them with you privately. So that's kind of where that is right now.
Yeah. So with that, I will say thank you very much. Appreciate you being here. We'll invite Jason back on to sort of say goodbye. Reach out to us if you have any more questions. You can send us an email here too, and we can hook you up with whatever you might need there as well. So with that, thank you so much, Cody, and I'll send it back to Jason.
Thanks.
All right. Well, thanks, guys. Yeah, definitely some pretty fascinating stuff there. I every day or every time Google does another release, I'm a little more excited about the future of AI. But I go back and forth, to be honest. Like, let's be honest. You never know if it's going to end us to the apocalypse or if it's going to take us to a new era of human existence. You never know. So it's just fun to play with and see what happens.
That's why monitoring is so important. We got to keep tabs on things, make sure things aren't going crazy.
We got to keep
physical off button
as long as possible, right? But cool. No, thank you guys. But I will say that if anybody can get data right, it's Google, right? They are the data kind of connoisseurs of everything, right? They kind of pioneered that whole thing. So very exciting to see. But yeah, thanks guys. Just once again to reiterate, Jason, yes, we will be sending out this presentation and all the available resources to all the attendees. And this webinar will also be available on demand after this point. So if you've got colleagues you want to share it with, feel free to point them in that direction. And then you can also reach out directly to Jason or Cody if you want follow-up questions there. Other than that, you can check out dzone.com/events for the rest of our events, other things that we've got going on. Give us about maybe 24 hours or so to have this webinar up there, but you can see all the other stuff we've had. And be sure to tune in next time for another one of our great events. Jason, Cody, thank you guys again so much for being here. I really hope everyone has a wonderful rest of your week, and we will see you guys next time.
Thanks, everyone.
Thanks, Jason. Thanks, Jason.